Welcome to Brain Vision.
In this problem, we have a shaft supported by some bearings along its length here, half a meter in from each end. On the left end, we have a 300 Newton point load. On the right end, we have a 600 Newton point load. Between the bearings, we have a 12 uniform distributed load that's 1200 newtons per meter. Now, if we place this with equivalent point load, do force and moment balances for the entire structure, we'll figure out that the support on the left is supporting 750 newtons, and that on the right is supporting 1350 newtons. So, doing our shear, in this region, we have a constant value, and again, because of the way we're taking our sign conventions, I should put a minus 300 in here. So it's minus 300 until we get to this point where we jump up 750, and then through this region we have a slope of minus 1200, and we come down here and down, and then when we get to this point we jump up 1350 newtons, and then that gives us to 600 newtons, which we have over here. And again, we should make sure that when we get to this point here, we know from going from the other way what this should be. So again, that's a good way to check to make sure that we actually get back up here to 600 newtons. Now, for the moment, in the outer regions, we have just a line, linear dependence. So the slope is minus 300 over here, and plus 600 over here, and both start at 0. Now in the middle here, we actually have a quadratic, and if we integrate what this curve is and then match a boundary condition here, or make sure that the moment is continuous at this point, we get that function is this: minus 75 times the quantity 7 minus 14x plus 8x squared is this parabola here. And again, we need to make sure that it and then agrees with this point here, so we can have some consistency checks kind of built into our solution. It doesn't necessarily mean it's correct, but just that it's consistent with what you would expect.